Hi, friends. It's me again. I am Joe Bautista, and I am pursuing this blog, which is on its second episode. Uh, I need to follow up on the issues that I raised in the first episode, and this time I'd like to touch on the metabolism of energy in the body and try to compare it with the other models and pathways that are found in not only in humans but also in animals. And of course, this channel is uh, called. So I purposely named this channel. I am a low carb dieter. Yes, that's true. And I don't have a well rounded personality. That's for sure. And you may be wondering why. Well, this is the reason why. I don't have a well rounded personality because I go easy on the carbs. Maybe it's just a pun to the low carb diet regimen, but it makes sense. If you go easy on the carbs, definitely you'll not be having problems on obesity and some other diseases. But for today, oh, by the way, before I forget, I'm sorry for the quality of the video last time. I suppose some of you wanted to leave their comments, but they could not because the comments section was turned off. Little did I know the new beginner that I was in the making of blogs and using YouTube as a platform. I didn't know that if you click a video made for kids, that the default is to turn off the comments. And I found out only I think yesterday. So the next time, and this time probably this episode, uh, I will make it sure that you can leave your comments just in case you do not agree to what I am saying, nor do you have any questions that you want to be cleared off, and I will try my best. But then, let's start by looking at the different pathways in the metabolism of energy in the body. In some ways, probably humans, animals, which are considered monogastrics. I think I mentioned that in the first episode. As well as ruminants have different pathways for the metabolism of energy. And there are basically two regular and normal pathways, one of which is the process called glycolysis. So it's basically the transformation of the ingested carbohydrates into a simple sugar called glucose. And this glucose is then stored whether in the liver or in the other parts of the body, particularly the muscles and the intramuscular spaces, as fat. In the liver, it is stored as glycogen. And when there is a situation where energy is needed, this is where the body sources its store of energy in the form of glucose, uh, but stored as either glycogen in the liver or fat in the other tissues. Now, why would glucose be so important? Those who have taken up chemistry, biochemistry, and physiology probably will remember that the currency for energy in the body, especially the brain, which requires a lot of energy, is nothing but glucose. So, if we talk of energy, we talk of glucose, and this is what the cells make use of to transform into energy. And mind you, at this point, I would like to say that the brain needs a lot of this substrate to use as an energy source. But then this is glycolysis. I guess most of my students, former students in the undergraduate program, including the master's program and the PhD program, would easily recognize this. I don't know if it is visible to the video, but enough to say that this is one of the pathways in the production of energy in the body. So this is glycolysis. It's the summary, and I know it will just bore the people who are watching who do not have any background on chemistry, biochemistry, physiology, zoology, or whatever. But enough to say that this summarizes the different pathways where starches, sugars, carbohydrate in the diet, probably except for the crude fiber, which I mentioned in the first video, will follow this pathway to produce a simple sugar called glucose and be stored in the body. If it is stored in the liver, it is stored as glycogen. If it is stored in the other parts of the body, it will be stored as fats. So take note, carbohydrates that undergo this pathway can be stored as fats. So if at this point you are wondering if ever there is truth to the what even doctors say, that when you eat fat, you deposit fat. And at this point in the low carb diet regimen that we're talking about, please forget that. That's not true. You eat fat, but you do not, out of the ingestion of fat, you do not store fat. Fat will only be stored if there is extra carbohydrate in your diet, and that these carbohydrates that are absorbed in the gut uh, then increase the level of blood sugar, and eventually this sugar, particularly glucose, is stored as either glycogen or fats. So I think that should be clear enough for those who still doubt whether the causation of obesity and the deposition of unwanted fat, because we have not yet debunked the different myths about fat. Anyway, so this is the pathway. Again, there are carbohydrates in the diet. The simple carbohydrates that are composed of starches and sugars are easily absorbed in the gut. They go to the bloodstream, circulate in the body, and those that are not used by the cells for the production of energy are then stored as, again, either glycogen or fats. So I think that's clear enough. But then there's another pathway. Okay. There's another pathway by which the body will metabolize energy for its needs. And on the left is what we have already discussed a while ago, and that is glycolysis. On the right, you see gluconeogenesis. So what's the difference? The difference is that in glycolysis, the production of glucose comes from the diet. So you eat starchy food or food that is rich in carbohydrate, you end up with the production of glucose that is either used immediately. It can either be used immediately by the cells in the body, or that, if not needed, this will be stored again in the liver or in other parts of the body. Particularly, of course, you know where those baby fats and the unwanted fats in your body are located. So that's where this extra unused glucose will go. Okay. On the other hand, there is gluconeogenesis. So you already have a store of potential energy sources, either in the form of fats or in the form of glycogen. Okay. Of course, there are still other sources of energy substrates. So we have already mentioned that a simple sugar called glucose can be a source of energy, but then it is stored as either glycogen or fat. And therefore, if there is a need for extra amounts of energy by the body to perform its function, it can also get these sources from the stored either glycogen or the fats. Okay? Now, what I have not shown here is the other pathway of producing energy, and that is from proteins. Now, proteins can be used as sources of energy by the cells in the body, but it has to undergo a more complex pathway wherein, proteins contain nitrogen compounds. And before the structure of the amino acid is used as a source of energy, it first has to shed off that molecule containing the nitrogen or the ammonia containing part of that molecule. So, in the breakdown of proteins or amino acids for use in energy metabolism, uh, first it has to come from the protein-rich parts of your body, like probably your muscles, and well, it will undergo a similar pathway like glycolysis and gluconeogenesis, more on gluconeogenesis. But the catch here is that there is a byproduct, and that byproduct is very rich in nitrogen. In fact, if those among you watching uh, could notice that when you go to the gym and follow a strict regimen to either maintain or build up your muscles or just lose weight, there are times that you binge too much on protein without carbohydrates nor fats. And in the end, of course, you can build up your muscles because of the exercise, but you also begin to smell like ammonia. So when that happens, it only means that the body has turned to the proteins and amino acids as sources of energy for the functions of the body. So I guess that's the summary of it. I don't need to go into detailed explanations because I know it will just bore those who do not have a background of physiology, biochemistry, and the like. Anyway, looking at this between glycolysis and gluconeogenesis, now glycolysis will be the usual pathway of the production of energy for most monogastrics. And these include the human species, the monogastric animals like pigs. So they use glycolysis more often than gluconeogenesis, which means that after glycolysis and there is an abundant supply of glucose in the blood, it is glucose that is directly used by the cells to produce energy. And now here comes the catch again. For this extra glucose to be stored either as glycogen or fats, there needs to be a hormone that has to be released that will take care of the storage. Well, in simple terms, it's like I don't know how to term it right at this point, but this hormone comes from the pancreas, and it is called, well, you guess it right, it's called insulin. Now, why do I mention that? Because in the past video that I made, we talk about diabetes mellitus and diabetes insipidus, type 1 and type 2 diabetes. And it is largely affected by insulin and the amount of sugar that circulates in your body. So, as a background, well, you can say that insulin is a very essential hormone for the regulation of your blood sugar. Now, in my research, this is what Dr. Lustig said. You know, insulin is becoming a problem because first, insulin stimulates growth. Okay? So that insulin is not only a hormone that takes care of the extra supply of glucose in your bloodstream, but that the effect on cells is that insulin can have that stimulus for the cells to begin to divide and increase or multiply in numbers. Okay? So at this point, I think that is clear. And, well, the problem today about the incidence of diabetes mellitus and insipidus is this. Either the body or the pancreas cannot produce much of the needed insulin to lower down the circulating supply of glucose in your blood, that's type 1, or that in type 2 diabetes, the pancreas is no longer able to produce insulin, and that the cells that are sensitive to insulin have become resistant. And this is what we call insulin resistance. So even if insulin is present, the cells that were formerly affected and stimulated by insulin to store extra glucose no longer are receptive. In a deeper sense, if you talk about cellular level of explanation, probably they might have lost the receptors for insulin. That's why these cells will not react to the effect of insulin, even if it is present. So it becomes a problem. So we have just identified the problem with glucose in the bloodstream. We have identified the role of insulin. And so why is it important in low carb diets? Okay. So it is very important because of the wanted and the unwanted effects of insulin. And these are the things that I want to discuss with you today. You see, Dr. Lustig says that insulin becomes a problem under several conditions. One, if insulin is no longer produced by the pancreas, in fact, the islets of Langerhans, or that the cells that are supposed to be sensitive to the effects of insulin have become resistant. They will no longer react. So that even if in cases where the blood sugar is high and that this sugar has to be stored in other parts of the body, it remains in the bloodstream even if insulin is released, or that insulin, like in the diabetics that we know, they get daily injections of insulin. But if the problem is that the cells that are supposed to react to insulin are no longer sensitive to insulin, then the blood glucose remains high. So it's a problem. And that is one of the problems of diabetics. Okay? So we talk of diabetes type 1, which is diabetes mellitus, and diabetes type 2, which is the cells have become resistant to insulin, or that the pancreas no longer produces the needed insulin supply to control the supply of blood sugar, especially at times after eating or maybe after having a snack. So that is basically the problem of diabetics. So again, how do we relate that to the low carb diet? Of course, where does glucose come from? And definitely it's from the diet. So as much as possible in the low carb diet, we want to have an intake that is low in carbohydrates. And we purposely do that because we do not want insulin to be liberated from the pancreas. Does it make sense? Of course. If you have less carbohydrates to digest, then the increase of blood glucose doesn't happen. And since there is a lower level of blood glucose circulating, then there is no need for insulin release from the pancreas, and more or less, the situation remains stable. Now, it is a low carb diet, as I said, because you have to cut down drastically on your intake of the digestible carbohydrates. But I think in the first episode, I told you about fibers or crude fiber, which is a form of carbohydrate. It's a complex carbohydrate, basically. And the problem in human nutrition is that these fibers are not digestible in the gut. Now, if it is not this crude fiber or fiber is not digestible in the gut, then what's the purpose of taking it in your diet? The purpose, as I said, is that this crude fiber, although it is not metabolized as a source of energy or whatever by monogastrics like humans, this crude fiber is very much needed by the microbial population in your gut or the small and large intestine. These are acted upon by these microbes, and as I said in the first video, these microbes, by using this crude fiber present in the gut, they use this fiber for their energy needs. And in the process of transforming this fiber into energy, they release what we call fatty acids. And some of these fatty acids are what we call the essential fatty acids. And I think in the first video, I told you about these types of fatty acids that probably you've been hearing already. So we have, at this point, we have the omega-3 and the omega-6 fatty acids. And I think most commercials and most nutrition or diet programs mention about the intake of fats. Sometimes they even refer to fats as either good or bad fats, either saturated and unsaturated fats, and that most of the time they refer to the saturated fats as the bad fats. Now, here's again the catch. Research, modern research is beginning to unravel the fallacies. You see, in nutrition recommended programs, you are told to shun away from saturated fats. And you are advised to take in the healthy fats, which are the unsaturated fats. What is the basic difference? And if I tell you about this, the difference between these two, I think you will be surprised. Because it doesn't matter on the structure at this point. It doesn't matter whether it is saturated or unsaturated fats. What matters is the fatty acid chain that is present in that form of fat. Okay? And there are some short chain fatty acids that are needed by the body, which promote the production of other hormones that promote good health. Okay? Now, before, we used to label fats or oils as good and bad. And largely, as a result of that hanky-panky that was pointed out by Dr. Lustig sometime in 1970s or 80s, when the article, the scientific article that was supposed to be published was suppressed, and instead they came up with this alibi that fats are bad for the health. And so it became a fad, and most diet programs began to take out the fat from the diet. And if you have to follow the logic of Dr. Lustig, then we have been fooled all the time, all along. And that's very sad because it's only up to now when we begin to notice that we have been fooled all along. And it includes all, even doctors have been fooled by this fallacy. And this is what the advocacy for low carb diet is all about. We do away with all the fallacy. We rebut all of the issues regarding the consumption of fats and proteins and the changing of the diets to a low carbohydrate diet. And as Dr. Lustig said, well, if the problem is on poor diets and poor nutrition, then probably if there is any disorder or disease that is caused by poor nutrition or poor diets, then it is only logical that the cure would be nutrition itself. That's why I am an advocate of the low carb diet, intermittent fasting regimen. Okay? Anyway, I think in the first video, I pointed out that since Dr. Josephine Grace Tan is a human doctor, a medical doctor, And even I think Dr. Lustig is also a medical doctor, meaning the practice is on humans. They might not be aware of what's going on with other types of animals. And I'm referring to the nutrition of ruminants. You see, what is unique what is unique in this point and linking it with the low carb diet is this. For ruminants, of course, they get their energy supply from roughages, largely roughages. So they transform the crude fiber into fatty acids in the rumen, the reticulum, and the omasum. That's where the fermentation happens. And in turn, these microbes break down the fibers that are ingested by the ruminant. In fact, that's why they are called cod chewers, because at some point in time, they regurgitate the ingesta coming from the rumen and chew it again. And after chewing it, then the ruminant will swallow it again. Now, if you take a piece of that cod and culture it in the laboratory, you will find that there is an enormous population of microorganisms. And it is these microorganisms that transform the crude fiber into fatty acids. Now, one thing more about these fatty acids, they circulate in the bloodstream of ruminants as fatty acids, contrary to what the human doctors and the other practitioners in animal nutrition, particularly on monogastrics. In monogastrics, the circulating source of energy, basic source of energy, is glucose. In ruminants, hardly can you see glucose in the blood. What you see is an enormous amount of fatty acids. Now, these fatty acids are of course used as sources of energy, but for example, in the production of milk, you may probably have come across the term lactose. And lactose is nothing but a complex chain of glucose and galactose. And they come from a single source of sugar, which is basically glucose. But if you go beyond that source, you will find that that glucose, which is then transformed into glucose and galactose, and then joined together to form lactose, basically comes from fatty acids. So, that is the point. And how do we connect that to the low carb diet? Well, it seems if you take this model that what circulates in your bloodstream is basically fatty acids, free fatty acids, rather than glucose, then probably you might get the idea there is hope for diabetics after all. See? Because in diabetics, the problem is a high glucose level in the blood, which can never be, or which is hardly stored to lower down the supply of glucose in the blood. So, as I said in the first video, probably Dr. Josephine Grace Tan, Rojo Tan, could look into the model of energy metabolism in ruminants so that they are able to understand. Of course, I understand because of my background as a veterinarian and professor in animal science. Okay. So, I guess I understand it better because I know the principle. Okay. Now, does gluconeogenesis occur in humans and monogastrics? Well, the answer is yes. And it happens only in extreme cases. When there is no longer any supply of carbohydrate in the diet, so that the blood glucose level is low, then the emergency reaction of the body is to source its energy from the stored sources like fats and proteins. No problem with using fats as sources of energy in place of carbohydrates or sugars. There is a little problem with the use of proteins and amino acids as sources of energy because of that ammonia containing compound that is liberated as a byproduct of the breakdown of proteins and amino acids into energy. So, uh, if you want to ask, then if fat is used as a source of energy, what are the advantages and disadvantages? Of course, there are advantages. And one of the advantages is that as far as the output of energy is concerned, if you compare fats as sources of energy and sugars or carbohydrates as sources of energy, there is a very big difference. For example, for every output of energy from carbohydrate, the output of a similar volume or mass of fat is three times the output of carbohydrate. You get more energy. And that is three times more energy than when you source your energy from carbohydrates. Isn't that an advantage? Well, think about it. Now, about the disadvantage. Well, the only disadvantage with the breakdown of fats into energy is this. There are in the bloodstream and which means that even in the peripheral parts of your body, some form of ketones will be present, and probably in your breath, you will smell that acetone breath. I guess between urea and acetone, acetone would be more tolerable to smell. But that's not a problem. It's a good one. Why? Because you lose fat. Isn't that your purpose in dieting, in exercising, in what we call healthy living? So now you know. Now, okay. So going back to that model of the ruminant, I guess Dr. Tan and Dr. Lastig should understand this because it's happening in nature. So here is one species of animal or a species of animals that probably do not have diabetes, I should say, because there is no problem with blood glucose, there is no problem with insulin. Why? Because what circulates in the blood is basically fatty acids, and that's the ruminant. And the only time that these fatty acids are transformed into the basic sugar glucose, which is the currency for energy in the cell, is at the time that it is needed. So fatty acids are transformed into sugars, basically glucose. So no problem. Now, to expand the thought, here is what you need to know. By profession, I'm a veterinarian. I teach, I practice largely on ruminants, and I do some nutrition practice as well in most of the farms that I consult with. I formulate rations if needed, so I know. There is just one big problem that I think I still have to research on, and it is this. especially for dairy animals, we are seeing a unique case of fatty liver syndrome among high producing dairy animals. Okay, let that sink in a little bit. We are seeing a syndrome of fatty liver among high producing dairy animals. What does that mean? You may think that I'm contradicting myself, right? I said in the beginning that the ruminants get their energy supply from the breakdown of crude fiber transformed into fatty acids. But how is it that some of these animals, especially the high producing, milk producing animals, develop fatty liver syndrome? Okay, here is the answer. We purposely give lots of carbohydrates as sources of energy to these high producing animals in order to support their high milk production potential. We already know that the animal can subsist on roughages, forages, grass for their energy needs. But since there is a demand to increase the supply of milk, we practically force these dairy animals to produce more by giving more of energy sources in the ration. And most of these sources of energy are not digested in the rumen. They are directly digested in the abomasum, which is the true stomach of ruminants. That's where the breakdown of these carbohydrates happen. And so, what happens? If there is a breakdown of these carbohydrates into simple sugars, then these simple sugars are absorbed in the bloodstream and coming from the gut, first they have to be or they have to pass the liver. And there they are deposited again, like in monogastrics, as glycogen. But then this is not the form that is supposed to be circulating in the blood. Because I said earlier that what circulates in the bloodstream of ruminants is not glucose, it is basically free fatty acids. And so that must be the problem because for glucose that has been absorbed in the abomasum or the true stomach of ruminants, you will need insulin. And that it is only on the action of insulin that this extra blood glucose in the ruminant bloodstream can be transformed into its stored or storage form, which is either glycogen or fats. But then we are seeing this syndrome in high producing animals. The only consolation here is that in high producing animals, those animals that produce more than 40 liters of milk, 35 to 40 liters of milk a day, and more, because there are already some dairy animals that produce even up to 100 liters of milk a day. So how is the system, particularly diet, supporting all this? That's a lot of energy that is needed to produce every single liter of milk by these dairy animals. And so, I don't know if you can make a connection. In the beginning, I said there is one basic question. If it is the free fatty acids that circulate in the bloodstream of ruminants, then are they prone to diabetes? Probably the answer is no. But then, on the other hand, if you feed them large amounts of carbohydrate because you want them to produce more milk, why do they develop the fatty liver syndrome? I don't know. maybe some of my listeners and viewers know the answer. But it's a good food for thought, and I'm sharing it with you because that's, from my point of view, is something that can be added to the understanding of the low carb diet and intermittent fasting. So again, at this point, this episode deals on the pathways for energy metabolism in monogastrics and ruminants, why there is a need for the practitioners, the medical practitioners who advocate low carb diets and intermittent fasting to look into the model of ruminants to understand energy metabolism and probably help out in improving the regimen that we know today. So I guess I've said a lot today, and I've touched a little bit on blood glucose levels, storage of glucose, utilization of glucose. So sometimes what I say may be too much for you. If you can stand it, then just take it with a grain of salt. However, those are my thoughts, a product of my educational background, my training, my experience. So I think I will have to expound on this in the next videos, but enough to say that the link between glucose and insulin is definitely a factor in the causation and control of diabetes. And if only we can control the spikes in the bloodstream for glucose, definitely we can control the release of insulin, and that we can control diabetes. Now, at this point, let me just tell you that as Dr. Josephine Grace Rojo Tanes said in her blogs, that there are already practitioners of the LCF intermittent fasting regimen who are diabetics, who are taking insulin, and because of the diet, the low carb diet and intermittent fasting regimen, they have graduated from insulin therapy. And that's good news. Okay? That's good news. So, after all, Dr. Robert Lustig was right. If the disorder is caused by poor nutrition, it must be, it must be, or we could be able to cure it also by nutrition. And so I leave you with that. I think I want to say more, but the length of this video is more than enough. And just to tell you, well, a confession I have to make to you. I am a neophyte with regards to making videos, uploading them to YouTube. So I'm not yet very much experienced in troubleshooting. The last video took me 3 days to upload, and I couldn't understand why it wasn't uploading. So probably I guess the editing will be better this time. The content I think is as I wanted it. So it's up to you, the viewers, to react. I will make sure that I will no longer click on that box which says that the video that I am going to upload with YouTube is for kids, because that will shut down the comment section. Well, I've learned my lesson. So till then, again, I say thank you for watching. Enjoy your life, enjoy your friends, and most of all, enjoy your food. So bye-bye for now, but please do not forget to like this video, to share this video to your friends, and of course, do not fail to subscribe so that we have something to look forward to in the future. Thank you, and have a happy day.